Welcome back. In this video we'll learn about the differences between synchronous and asynchronous functions. Now, to understand the differences between the two, first you need a basic understanding of the architecture of a computer. So a computer has three main components we're concerned with. The first is the CPU, or central processing unit, and this is where code actually gets executed that you write for it to run. The second is RAM, or random access memory, and this is where memory that the program needs to run is stored. So for example, if you're using a user application or playing a video game, then the graphics for that user interface or the video game might be loaded into RAM. And the third is the hard drive, and this is where files are stored more permanently. So for example, if you decide to save an image on your computer, that will be saved on the hard drive. Now the key thing to note is that of the three components, the CPU is the only one that actually executes code, and the CPU is much faster than the other two components. So if you take a typical web server example, say you want to serve a HTML page to somebody, then the CPU processes the code to receive the request, determines the file path to read, and then it asks the hard drive to read the file. Now that part takes a long time, and if you have no other code to execute, then you can just imagine the CPU is just sitting around and waiting for the hard drive to do its job, all while it's doing nothing at all. And so this really slows down a web application and means that if you run code in the traditional way, synchronously, then requests can take a long time. So now you understand a little bit about that, we can look at the actual differences between asynchronous and synchronous functions with an example. So first of all, we'll go for the synchronous one, which is the one you'll be most familiar with if you've done programming before. So first of all, we just import the file system module, and then we read the file synchronously called hello.txt, and we just specify that we are expecting UTF-8, which is basically text back. Then we print out the contents of the file, and afterwards we print out a statement that says I'm after read file, and it's just saying this is a statement after read file, and the reason for that will become more clear when we look at the second example. But anyway, if we now quickly run this example, you'll see it prints out the contents of the file, hello world, and then it says I'm after read file, as you would expect if you're used to standard programming. Now here's an asynchronous example, and if you've ever done event programming on the front end with JavaScript, you'll be familiar with this from like mouse clicks or whatever. So first we get the file system module again, and then we do this asynchronous version of read file, passing in the same file name, and we want text back, and then we're registering a callback function. Now if you've ever done event programming, as I said before, then if you, for example, register something for an on click of a mouse or on hover in JavaScript and pass it a function, this is a similar thing. You might be unfamiliar with this notation up here. This is just called arrow notation, and this is the modern way of making asynchronous functions. So the way you could do it instead is like this. This might be a way you're more familiar with. So you say function and then the parameters and then you execute it. This arrow notation is just a cleaner way of writing the same thing, but it still registers a callback function. So what will happen is read file will read the file, and then once the file has been received from the hard drive, it will call your callback function to be executed, where we just check for an error, and if there's an error we just throw it and the program will crash. Otherwise we print out the contents of the file. Now after the read file function's been executed, we put the same statement in as before, I'm after read file. So now if we look at it in being executed, you'll see there's a bit of a difference. So you'll see that I'm after read file comes first, and then hello world comes second. Now the reason for this, if we go back to the example of the CPU being fast, is the CPU is doing something else instead of just twiddling its thumbs. So once we ask for the file to be read, and while it's waiting for the hard drive, it decides, well, we can do something else. So the CPU is not just wasting time doing nothing, and it goes on to execute the next statement in the file. Now you can imagine if you're running a big web server, this functionality is really useful if you've got multiple requests for different files. While you're waiting for one file to be read, you can be dealing with somebody else's request and executing the code for that, and this really speeds it up. Now if you're a bit confused about this asynchronous programming and you haven't seen it before, then that's understandable, and I'm going to assign you a mini task to do that will help you to understand the differences between them via experimentation. So what I want you to do is I'm going to provide a HTML file, which is a web page, and I want you to serve it asynchronously, so this way, in this file, and also synchronously, so the way I've done it in this file. And the reason I want you to do it that way is so you can experiment it with yourself and through trial and error to kind of wrap your head around the idea of asynchronous functions and make sure you're comfortable with them, because we'll be using those quite often throughout the course as it makes for a more efficient application. If you have any problems with the mini project, then I'll post a potential solution and instructions for the project in a folder that you can see. And afterwards, if that all goes okay, then we'll explore HTTP response codes, which is an important concept to understand for producing web apps that follow the HTTP standard.